Memory compression, a new feature in vSphere 4.1, offers improved memory performance protection in memory overcommitted virtual environments. Memory compression is used in conjunction with VMware's other memory overcommitted technologies, such as transparent page sharing and in-guest ballooning. This demo will show the performance gains that memory compression can provide compared to the alternative of swapping memory to disk. In this demo, we have two identical virtual machines running a simple memory performance testing tool. Each virtual machine is running on its own ESX server. One ESX server has memory compression disabled and the other has memory compression enabled. Memory compression is enabled by default in vSphere 4.1, but we have disabled it on one host by editing the advanced settings. Both virtual machines have 600 megabytes of memory assigned to them, and they are using all 600 megabytes for private memory. You can see that both virtual machines have roughly identical performance as indicated by the simple performance testing tool running in each virtual machine. We will now simulate memory pressure by setting the memory limit for each virtual machine. We will set a limit of 400 megabytes, forcing the ESX host to reduce the amount of actual physical memory the VM is allowed to use. We will set the same memory limit on the other virtual machine. We see that after setting the memory limit, the performance of the virtual machine with memory compression disabled drops significantly. On the Resource Allocation tab for the virtual machine, we can view the virtual machine's memory usage. In the case where we have disabled memory compression, we can see that 200 megabytes is being swapped out and 400 megabytes is remaining in the private physical memory. Because swapping memory in and out of storage is a relatively slow operation, performance in the VM is significantly impacted. Now when we look at the virtual machine running on the ESX host, where memory compression is enabled, we will notice that the performance has dropped some, but is still significantly better than the virtual machine with memory compression disabled. In the Resource Allocation tab for the virtual machine, we see that a portion of the memory is being compressed in order to reduce the amount of memory that needs to be swapped out to disk. Some memory may still need to be swapped in order to satisfy the memory limit placed on the VM, but the amount needed to be swapped is significantly reduced. Lastly, notice that the private memory available to the VM is less than the memory limit assigned to the VM. Memory compression is an in-memory operation, and the compressed memory continues to remain in physical memory in a compression cache. The difference between the memory limit and the private memory is the amount of memory used by the memory compression cache. In-memory compression and decompression operations take on the order of microseconds, whereas swapping can take on the order of milliseconds, up to 1,000 times slower than memory compression. By utilizing memory compression, you can get the most out of your virtualization environment while maintaining a higher level of performance. For more information, please visit vmware.com.